Any questions?
Yeah, could you try and do a problem? It was similar to one on the master set this week. It was a conservative force F equals 3 newtons I hat plus 2 newtons J hat, and a non-conservative force of F equals -2 J hat, are applied to an 8 kilogram object between the position 1 and
And that was what's the final speed?
2. After 5 meters. Speed after 5.
All right, why? All those are off. That's power down. And stop. Excuse me. All right, so it's exploiting the idea that the total work is equal to the change in kinetic energy. And the clues in the problem that tell you this are the fact that I told you the conservative and non-conservative force, so you can find the total force, as well as you're trying to find speed, which is associated with kinetic energy. And it's that chapter which has work energy. Well, work, I know, is the total force times the displacement. Okay, final minus the initial. Well, the total force is conservative force plus the total non-conservative force. So if your conservative force by newtons I hat plus 3 newtons J hat, and the non-conservative force -7 newtons I hat minus 3 newtons J hat. Well, what's the total force? Like you mean it.
-2 newtons I hat.
Yes. If that's my total conservative and total non-conservative, I mean, those are the only choices. There's not a third type of force when you're categorizing like this. Just add them up. You know, and you'll notice that if you add them up on that problem, the J components go away. Now the displacement, so I got -2 newtons I hat, dot product with my displacement. And let's say I go from, my initial position is 3 meters I hat minus 4 meters J hat, and my final position is 10 meters I hat plus, it really doesn't matter, YJ hat. What's my displacement?
Um, 13 meters I hat.
What is displacement?
7.
You're gonna have to talk louder than that.
Is it 7 meters? I have 7 meters.
All right, so I got 7. How'd you get 7 meters?
I guess because the initial's 3 meters I had and the final's 10 meters I had, so displacement 7.
Yeah. So if you go from 3 to 10, or
10 minus 3.
that's displacement, so that's final minus initial. So 10 minus 3. So 7 meters I hat, let's finish it off.
Would be, y minus 4 meters j hat.
No, but close. Why'd you say y minus 4?
Because the y is the final, so it would be the final minus the initial.
Okay. And what's the initial?
The initial is 4. Oh, it's y plus 4.
Yeah, y minus negative 4 or y plus 4 j hat. So I got 7 meters I hat plus, I really don't care, j hat. Now, why do I really not care about the j hat component?
Well, now, because we have the plus next to the 4, we can make it minus. There we go. Gonna be 2 parts, will it?
Wait, you're talking over here?
Yeah.
It's
I get what-
final minus initial, so it's y minus negative 4.
Right. And that makes a plus, but why is
Yes.
there another plus?
Here?
Oh, no, I can do this, never mind.
Okay. Glad I could help. Why do I not care about the j hat component? Let's work on the language. I'm gonna go with the spirit of what you said was right, but I have no idea if it's vertical or not.
Because, we're only concerned with the I hat.
Why?
We're just moving horizontally.
You're wanting to find the speed in horizontal
Okay,
direction?
jump to step. Now, some of you are making the assumption of I hat is horizontal and j hat is vertical. That's the language we're working on here. I've made no, the only assumption that I will accept on I hat and j hat is that they're perpendicular to each other.
There's no force in the j hat, no net force in the j hat.
And why is that important? Other people can chime in, since Carolyn has given you a chance to cut her off.
Would it not be j hat because there's no force acting in that direction?
And why is that important?
Because if there's no force, it's not going that direction. It's gonna go the one with the force, or the direction with the force.
What's the symbol on the board which tells you that's the way we're to approach this? No, it's not the Y. The dot. It's a dot product. Dot product multiplies parallel components. Since there is no J, or technically the J hat component is 0. When I multiply the J hat components together, it doesn't matter what that is, I'm gonna get 0. So, we end up with negative 14 joules. Obviously, that's not the final answer. I believe in that problem, I gave an initial velocity. 6 meters per second I hat plus 3 meters per second J hat. But kinetic energy cares about speed, not velocity. So what is the initial speed? Or how would you find it?
Pythagorean theorem.
Yes. After that big deal of I hat and J hat, well, they're perpendicular to each other, so. Actually, I care about speed squared, which is just VI dot VI. So 36 plus 9 is 45, which is VI squared.
Can you find the square root of that?
If you want to know the exact actual speed, yes, you would do the square root of that. But it turns out we actually don't need that because K final minus K initial, 1/2 mv final squared minus 1/2 mv initial squared. We only care about vi squared. You're looking at me like there's something missing there. Do you want to know the initial speed?
Well, no, it was just, I think that what I did on I think I know what this is referring to, because I remember doing Pythagorean theorem, but I remember simplifying, I don't know.
Yeah, some people find the initial speed, and that's fine, and then you just end up squaring it again. You take the square root of one point, and then you square it.
Oh,
You should end back where you started, in a sense. There's no harm in that. If you enjoy math, by all means, please do. Maths, I guess I never gave you maths here. Let's make it a nice number. So the total work done is negative 14 joules, and that is equal to 1/2 times 10 times VF squared minus 1/2 times 10 times 45. And if I had been thinking a little bit more clearly, I would have made it 20, but I didn't. Actually, I could just multiply by 2. How about if I multiply by 2 and divide by 10? So I'm going to multiply everything by 2 and divide by 10. In essence, divide everything by 5. So I get negative 2.8 is equal to V final squared plus 45. Negative 2.8. Bring this over. I get negative 47.8 is equal to VF squared. So VF equals what? Without a calculator.
seriously?
Yeah.
You're taking the square root of a negative number.
Yes. So what does that tell you?
It doesn't exist.
Either that or
Zero, undefined.
well, 0 and undefined are very different.
Is undefined.
It's either undefined, so it's either an impossible problem or what's the other alternative?
You did something wrong.
Yes. So one of those two things is true. But regardless, this is the process. And as a hint, the answer is not imaginary on the master set.
Can you do,
Oh, we did make a mistake. Near the end. Because I was thinking through the problem, and usually on a number of them I can think through and go, okay, yeah, that makes sense. But I start out with a certain amount of energy. I lose 14 joules. So the only way this would be impossible if I started out with less than 14 joules, fewer than 14 joules. Well, I started out with that. That's bigger than 14. So if I lose 14, I'm not into the imaginary zone. The mistake is there. It should be minus, not plus. So this becomes 42.2. And so whatever the square root of 42.2 is. I would expect, bless you, I would expect you to actually figure that out, not just leave it like that.
6.5.
It's what?
I believe it's 6.496, so
6.496?
1, and then 5, and then 2, and then 7, and then
Since we lost kinetic energy, I would assume that this is slower than what we started with. And, well, it would have to be. Square root of 45 is bigger than that. Or Ibrahim lied to me. Was your question answered?
Yes.
Okay. Other questions?
Can you do another one where, can you do another one of the momentum problems
Okay.
where,
Any other questions on the work energy stuff?